Okay, so I want to demonstrate muttix in the case of what I'm going to call the matched roots case. One matched root case. Okay? That probably doesn't mean anything right now. Don't worry about it. So, point is, how do you solve a non-homogeneous second order linear
differential equation?
No. Constant coefficient differential equation? Yeah. Set it equal to 0, solve the homogeneous version, right? Okay, so you go to the homogeneous equation. Okay? Once you're at the homogeneous equation, what do you do?
Auxiliary equation.
Go to the characteristic or auxiliary equation. So you got r squared plus 3r plus 2 is 0. Then you solve this using
-2. Algebra land.
Algebra land, which is this is the same example I did earlier.
Yeah.
So we get r plus 2 times r plus 1 is 0. So we get r is minus 2 or r is minus 1.
Sure.
Okay? So what's our general solution look like? Y is
C1 e to the -2x.
plus c2 e to the negative x, right?
Yeah.
Okay, and then you note the thing that makes this annoying, which is
That e to the -2x.
that is the matched roots thing. That's what I meant by matched roots. So normally, right, my guess for what would work in here, like to solve the non-homogeneous one, usually what I do is I say, okay, solve the homogeneous one, get an answer, and then look at the right-hand side and think about it. Right? So if you look at the right-hand side and think about it, what kind of junk are you going to differentiate, add to itself, and still get some e to the minus 2x's?
E to the -2x.
Yeah, you're going to think, dude, that looks like you took some e to the minus 2x's and fiddled with them. Right? So your guess for your particular solution, so your guess for yp is going to look like, well, yp is probably, oops, I need an a, e to the minus 2x. Right? Because duh. Okay, but
If a is a constant, then that'll just wrap into the C1 e to the -2x.
yeah, that thing turns into this. Why?
Because they're both.
Because you add them.
Yeah.
They're
You
both
add your
just
YH and
So-
your YP.
constant.
If you plug this into here,
You'll get 0.
you'll get 0 on this side, right? Why? Because I know it's a solution to the homogeneous version,
Oh.
right? I just solved the one where it equals 0, and I got that thing. So if I guess this thing and plug it in, I'm going to get 0 out. I know I'm going to get 0 out.
You don't want 0.
Yeah, I don't want 0. I want e to the minus 2x. Right? Okay, so what do you try?
Is that
Square it, maybe? E to the -2x.
we add something to our YP solution?
Okay, so what if I had the same root twice?
Add x.
Slap an x on it.
To get to the second one, I'd slap an x on it.
You can do that.
If I slap an x on this one, because it's not repeated, it's not going to be a solution for the homogeneous version, right? But maybe enough of it'll drop off that it'll still work. You guys see that? So I know this isn't going to work, right? Not going to work because of the match with the homogeneous version. So instead, I guess yp is, what's your best guess?
ax
ax
e to the -2x.
e to the negative 2x.
Could we arrive there, like, if we said, I think in the book they said, like, we'll just pretend a is a function of x.
Sure,
And
let's try it.
you'll end up at the same place.
So what if instead of guessing y is a e to the 2x, what if I guessed y is a of x e to the 2x, e to the minus 2x, right? Then I differentiate, so I get y prime is Yeah, and I'm going to stop writing the of x here, right? So I'm just going to take a as a function of x. So I got a prime e to the minus 2x, and then
Minus 2a e to the minus 2x.
minus 2a e to the minus 2x. That's a product rule, right? And then y double prime should be
A double prime.
a double prime e to the minus 2x
Minus 2a prime.
minus 2a prime e to the minus 2x. So that's, for the sake of clarity, those two pieces came from
The first term and
this first guy product rule, right? And then this guy product rule is going to give me
Negative 2a prime, negative, positive 4a prime, e to the minus 2x.
how about negative 2 times this stuff again. You guys see that? Because you already differentiated that thing by itself. Right? So you may as well use that back. Just cram this stuff in, and you have an extra negative 2 on it. So I got a negative 2, an a prime e to the minus 2x, and then a minus 2a e to the minus 2x. You guys with me? Okay? Then you take all of this jazz and plug it back in up here. Blah. Right? So you're going to get a double prime e to the minus 2x.
minus 4.
Oh, let's see. So I can at least simplify something. These two terms go together. Right? So I got a minus 4 a prime e to the minus 2x
Plus 4.
plus 4 a e to the minus 2x. Okay, so all this crap is y double prime. Right? And then I need a bigger whiteboard.
3 times the quantity,
So-
prime e to the minus 2x minus 2a e to the minus 2x.
Perfect. So my plus 3a prime e to the minus 2x minus 2a e to the minus 2x. And then plus 2a e to the negative 2x. And then this is supposed to equal e to the minus 2x, right? And in the end here, I'm solving for one unknown, which is a, right? And a is a function. So let me see what I got. Anything going to cancel? God, I really hope something's going to cancel here, right? So I could certainly multiply through by e to the 2x, right? And that'll drop all the exponentials out of there. So if I dump all the exponentials, I'll have a double prime minus 4a prime plus 4a plus 3a prime minus 6a. So I'm doing a little distributing as well. And then I got plus 2a equals 1. Okay. And combine like terms, and woo! The regular a's go away, right? That's 4a's minus 6 plus 2 is no freaking a's. Which is good, right?
So
Because I was still in non-homogeneous second order differential equation with constant coefficients there. You guys see that? Like, I was going to be in trouble again. I was going to have to do the same process, like find an auxiliary equation and dork around with it.
So a double prime minus a prime is equal to 1.
Yeah, so what I got is I got
So
a double prime minus 4.
not minus 4a.
Just a prime, just minus
4a
a
is
prime.
equal to 3a.
It's 3a.
Oh, yeah, cool. So I got a double prime minus a prime equals 1, right? You guys see that? Okay. So
Integrate with respect to.
yeah, you could just like maybe eyeball a solution. So what if A is X? If A is X, I got A prime is 1, and A double prime is, yeah, so I get a minus X, I guess. You guys see that? But I found A is minus X will work. Right? And I don't really care about the constant because I'm going to absorb that into my guess anyway. You guys with me on that? Okay, so this is how you would demonstrate that X is a good guess, right? Up to a constant at least. You could also like
solve
this thing a little better and probably you could come up with another good guess.
E to the 2x?
E to the 2x. What?
Where that's
Where?
For A.
For A?
Yeah. Down the bottom. Oh.
Yeah, it's A. I mean,
Oh, actually, that might have been.
So I guess
I might have messed that up.
A
I was
is
thinking
E
A
to,
prime is e to the 2x.
yeah.
That would work, but I don't know if that works.
so if A is E to the 2x, then A double prime is 4 A
Then
to
it's 2. And now.
yes. So
I was thinking A prime.
and I
is-
think you got an E to the 2x in there still, right?
Yeah.
You guess that like the exponential.
Oh,
I
it's
could-
not, okay, I was thinking coefficient of 1. It's not actually.
Is A always gonna work out to be that like convenient, or what if it gets super ugly? Like, how would you solve then for
So I don't need you guys to do this technique, right? You don't have to do this every time. You could just be like, yo, dog, the good guess is going to be X. Like I'll just slap an X on it. I want you to know why that works. Basically, it's another variable substitution, right? Like this is a little bit like variation of parameters, and then you just kind of tweak it. And at the end, you get something that you can solve kind of reasonably. If you do this every time, yeah, you're going to come up with something like this. Good thought?
Like the normal A's will just always drop off in this particular case.
Yeah, so as long as what you're guessing is already a solution to the homogeneous, or as long as you're running into this matched roots problem, yeah, the regular A's are going to drop. And the reason they're going to drop is that thing's the solution to the homogeneous equation. You guys see that? Do you have a question?
Yeah, you said that we didn't have to do that every time. At what point would you try to start guessing what A is?
Okay, so here's what I want you to do. Every time, you're in the matched roots problem, right? Like, okay, so I solved this. I saw that this matched that.
Yeah.
So my normal guess of just guessing this thing with a constant on it ain't gonna work. So instead, what I'm gonna guess is I'm gonna guess YP is AX e to the minus 2.
Okay. And then
Like, I want you to know that if there's a matched root problem, you slap an X on it. Okay? So now you could solve this, right? So to solve, what would you do?
I would take a prime of that.
Okay? So you do YP prime is some product rule stuff, right?
Yeah.
Okay? I probably dorked that up.
Yeah, isn't it a function of A of X? A isn't really
So now that I know a good guess, I'm just going to guess A is a constant, X is my function.
Okay.
Right, this is basically back to where I was at the beginning where I was like, hey, if this matches, the e to the minus 2x isn't going to work. So I know that a way I could have a similar thing without running into that problem would be to put an x on it. So I'm going to try putting an x on it, but I still don't know what the constant is.
So then if you treat A like a constant, it'll work out just like every other problem, then you know like
Yep.
maybe 2x, 3x, whatever.
So let's finish this, just see how it goes.
Okay, so just before we got into this part, after we got our value for A, right, we plug it back into the y of p, and then we add that to our y homogeneous, right? And that gives us our y equation.
Yeah, so once I get a particular solution, like once I find out what A is, I'm going to take that information and I'm going to stick it back onto this.
Yeah, okay.
Okay, so what's YP double prime?
Oh, it would just be, A times the, negative 2e to the negative 2x
Good?
minus, plus, 4x e to the negative 2x.
And then the other one.
The other one, negative 2e to the negative 2x.
Plus. Yeah. He didn't.
You did it backwards. So these two here came from the product rule on that thing times negative 2. Right, so this whole thing should be negative 2 times what you had up here. So that's an e to the minus 2x minus 2x e to the minus 2x. Right, you already differentiated this part once up here. So keep it constant. Okay, so you got all this jazz, and then you what? Yeah, so you could maybe combine like terms, right? Okay. So also here I got minus 4a e to the minus 2x plus 4ax e to the minus 2x. Right? Okay, so then what? What am I trying to do? Yeah, I'm trying to solve for a. So take those three things. Right, I don't need this one anymore. I take this guy, and that guy. Right, your prime, double prime, is regular. Plug them back into the original equation, solve for a. So I have in my original equation a y double prime. So I got minus 4a e to the minus 2x plus 4ax e to the minus 2x. Right? And then I have a plus 3a e to the minus 2x minus 6a e to the x e to the minus 2x. You guys with me on that? And then I also have a plus 2 ax e to the minus 2x. And this is all supposed to equal e to the minus 2x, right?
Yeah, do the same thing.
Yeah, so I could multiply this whole thing through by e to the 2x. And maybe I can combine some like terms.
Yeah.
You guys see any like terms?
Well, the AX's cancel again.
Let's see. So I've got, this term's got 4 AX's,
That minus 6 AX's.
minus 6 AX's, and plus 2 AX's. Oh, that zeroes out. Why did that zero out?
Minus 1
Because it's a matched root.
Yeah, because e to the minus 2x was a root of the homogeneous equation, right? So some of that crap's going to cancel. Luckily, it's the stuff with the x's on it. If it wasn't the stuff with the x's on it, you'd be totally freaking hosed.
2 and now is one equation.
Right? Because you'd have x e to the minus 2x's over here and e to the minus 2x over there. Those aren't going to ever match. Right? So you'd be just like, oh shit, that guess didn't work. Maybe I'll go do something else with my day. Right? But luckily these guys cancel. So when those guys drop out,
Minus A.
I got minus a equals 1. Which is that minus x I got before. Right? You guys see that? I didn't even know I had it in my hands. Of course I had it in my hands. Right? Because I was purposely solving for a. You guys see that? This way's a lot easier, right? Because I didn't have to go through that whole rigmarole of like solving a differential equation about a. I just got to like solve for a constant. You guys see that? So if you know the guess ahead ahead of time, right? If you know you should be guessing x times e to the minus 2x, then your life's a lot easier. You can just find the constant that goes with it.
Okay, so that's what you're talking about guessing, is that you just do x, e to the 2x, or whatever it is, and solve for what a is.
Yeah, so
Okay.
if there's a matched root, so like you look at this thing and you look at the homogeneous version and you say, okay, is the non-homogeneous part, does that match one of the homogeneous solutions? If it does, I'm going to slap an x on it. What would you do if it matched both of them? Slap an x squared on it. Nice. What if it didn't match either of them?
Good to go.
Yeah, then you just guess it and fine, right? It'll work out just in.
So guess it with an A?
Yeah, you guess it with a constant.
No.
Same with the x squared.
No x's.
Okay.
You guys cool with that? So, let me wrap this up. What did I finally get as an answer here?
A equals, yp equals negative x e to the minus 2x.
Okay, so I found my yp. It's negative x e to the minus 2x. Okay, so then what's your whole solution?
Y equals c1 e to the minus 2x plus c2 e to the minus x.
Hang on, so, sorry. c1 e to the minus 2x plus c2 e to the minus x.
Minus x e to the minus 2x.
Perfect. Minus x e to the minus 2x. Boom. Done. Okay. Cool.
And if this were an IVP, this is where we would plug in, right?
And if this was an IVP, then you'd plug in the initial conditions and you'd pray for skills with algebra.